Question number 11. Assertion A. Root 3 plus 1 all square is a rational number. Reason R. Root 3 all square is equal to 3 is a rational number. Option A. Both assertion A and reason R are true, and reason R is the correct explanation of assertion A. Option B. Both assertion A and reason R are true, but reason R is not the correct explanation of assertion A. C. Assertion A is true, but reason R is false. D. Assertion A is false, but reason R is true. So first we have to check both assertion A and reason R. Reason R is true since root 3 all square is always 3 and is a rational number. So the reason R is true. We have to check whether assertion A is true or false. So root 3 plus 1 all square is equal to, we can express the expanded form. We know a plus b all square is equal to a square plus 2ab plus b square. Here a is root 3. So root 3 square plus 2 into AB. AB means root 3 into 1 plus B square, which is 1 square. So the answer is root 3 square is 3 plus 2 into root 3 into 1, that is 2 root 3 plus 1 square is 1. So we can simplify 3 plus 1 4, 4 plus 2 root 3. Here 2 root 3 is an irrational number. Therefore addition of irrational and a rational number will get an irrational number. Therefore 4 plus 2 root 3 is irrational. Therefore we can conclude that root 3 plus 1 all square is an irrational number. So the assertion A is false. So the correct option is assertion A is false, but reason R is true. So the answer is D. Question number 14. 7 into 29 into 23 plus 1 is option A prime number, B divisible by 23, an odd number, a composite number. Here the question is 7 into 29 into 23 plus 1. So we can do the first multiplication. So 7 into 29 is equal to 7 into 9 into 6 is 14 plus 6 is 23. So 203. Next 203 multiplied by 23 is equal to 0 6. So we get 9664. So the answer is 4669. Next we can add plus 1. So 4669 plus 1 is equal to 4670. That is 4670 can be written 406 467 into 10, and here 10 can be split by 2 into 5. So we got two factors 2 and 5, also 467, that is 4670 has more than two factors other than 1, that is 4670 is composite number. Option D is answer. Question number 15. Assertion A. 4 raised to n cannot end with the digit 0. Reason R. Prime factorization of 4 raised to n is unique. A. Both assertion A and reason R are true, and reason R is the correct explanation of assertion A. B. Both assertion A and reason R are true, but reason R is not the correct explanation of assertion A. C. Assertion A is true, but reason R is false. D. Assertion A is true, but reason R is true. Let's check reason R. Prime factorization of 4 raised to n is unique. Yes, by fundamental theorem of arithmetic, prime factorization of any composite number is unique. Therefore, the reason R is true. Assertion A states that 4 raised to n cannot end with the digit 0 for any number which is end with 0. Its prime factorization must contain both the prime factors 2 and 5. So that 2 into 5 is equal to 10. So the number can end with the digit 0. So 2 and 5 must contain in the prime factorization of the number. In 4 raised to n, we can write 4 as 2 by 2 raised to n. So 2 the power 2 raised to n, that is equal to 2 raised to 2n. That means only prime factor in 4 raised to n is 2. That is, there is no 5 as a factor. That is, 4 raised to n cannot end with the digit 0. So the assertion A is correct. A is also correct, and reason R is also correct. So we can conclude that both assertion A and reason R are true, and reason R is the correct explanation of assertion A. So the correct option is A. Question number 16. 7 into 11 into 13 plus 5 is a prime number, an odd number, a composite number, a multiple of 5. So we can see that 7 into 11, that is equal to 77, and 77 multiplied by 13, 1001, and now adding plus 5 we get 1006. Now we can do 1006 is an even number, so we can divide it by 2. Then we have 53, that is 503 is a composite, is a prime number which cannot be divided by any number other than itself. So 1006 is equal to 2 into 503. So there are two factors other than 1. Therefore, 1006 is a composite number. So option C is the answer. It is a composite number. Question number 17. Find the HCF and the LCM of 1530 and 2040. So first we have to find the factorization of 1530. Since 1530 is end with 0, it is an even number and it can be divided by 2. We get 765. So the factors of prime factorization of 1530 is to the power 1 multiplied by 3 the power 2 multiplied by 5 the power 1 and multiplied by 17. Next we have to find the factors of 2040. It is an even number, so we can divide it by 2. So the prime factorization of 2040 is to the power 3 multiplied by 3 the power 1 multiplied by 5 power 1 into 17. So HCF equal to of these two numbers is the common factors are 2, 3, 5 and 17. Its least powers, that is in 2 to the raised to 1 is the least. So to the power 1 multiplied by 3 the power 1 multiplied by 5 and 17. So HCF is equal to, so 510. Next we have to find LCM. LCM is 2 raised to 3 multiplied by 3 the power 2 multiplied by 5 and 17, that is equal to 8 into 9 into 5 into 17, that is equal to 6120. Next we have the question. The HCF of 960 and 432 is option A 48, option B 54, option C 72, option D 36. Nine 60 can be factored as by 2 we get 480, by 2 we get 240, by 2 we get 120, and by 2 we get 60, 30, 15. So the factorization of 960 is to the power 6, 3 raised to 1 and 5. Next 432 can be divided by 2. 2 and 6. By 2 we get 108. by 2 54, by 2 we get 27, and it can be divided by 3 we get 9, by 3 we get 3. So the factorization of 432 is to the power 4 multiplied by 3 raised to 3. Therefore HCF is equal to the power 4 multiplied by 3, that is 48. So HCF is 48, option A. Question number 19. The natural number 2 is a prime number, a composite number, prime as well as composite, neither prime nor composite. A prime number is a number which has exactly two factors, 1 and itself. Let's see, 2 is a prime number because it has factors 1 and 2, exactly 1 and 2. So 2 is a prime number which is not a composite number. For a composite number there must be factors more than two factors. So the answer is a prime number.